Imagine a time, before light, before darkness, a point infinitesimally small containing all the energy of our universe. Then an explosion, an expansion unlike anything imaginable. This was the Big Bang. 13.8 billion years ago, the universe was born. Space itself expanded, cooling as it went. Energy, once unimaginable, began to coalesce. Particles formed, quarks, electrons, the building blocks of matter. The universe, once a sea of pure energy, began to take on structure. But the universe was still young. It was a chaotic, violent place. Gravity, the great sculptor, began to exert its influence. Clouds of hydrogen and helium, the simplest elements, drew together, pulled by their own mutual attraction. These clouds, vast beyond comprehension, became the nurseries of stars. In a quiet corner of the Milky Way galaxy, one such cloud of gas and dust swirled and churned, creating a cosmic dance. Gravity relentlessly compressed its core, raising temperatures to unimaginable and extreme levels. Atoms, once content to drift in isolation, were slammed together with unimaginable force. Nuclear fusion ignited, hydrogen atoms fused into helium, releasing a torrent of energy. A star was born, our star the sun. The sun blazed with youthful energy, bathing its surroundings in brilliant light and heat. Around it, the remaining cloud of gas and dust continued to spin and swirl. This swirling disk, a chaotic mix of leftover star stuff, held the seeds of planets to come. The sun's heat pushed outwards, driving away the lightest elements. Close to the young star, only heavier materials like rock and metal could withstand the intense pressure and heat. Further out, ices and gases lingered, forming a vast, distant disk. Within this swirling disk, particles collided, stuck together and grew. Dust grains became pebbles, pebbles became boulders, boulders became planetesimals. Gravity, ever the architect, drew these planetesimals together, building the foundations of planets. In the inner solar system, 4 rocky planets began to take shape: Mercury, Venus, Earth, and Mars. Each was unique, shaped by its distance from the Sun and the composition of the material from which it formed. But their stories were far from over. The early solar system was a chaotic place, a cosmic billiards table where planets in the making jostled for position. The young Earth was a world of fire. Constant bombardment by asteroids and comets released unimaginable heat, keeping the planet in a molten state. Volcanoes erupted across the surface, spewing lava and gases into the primordial atmosphere. But amidst this chaos, a delicate balance was being struck. Earth, with its iron core, generated a magnetic field, a shield against the sun's relentless radiation. This magnetic field, invisible but vital, would become crucial for life as we know it. The early solar system was a place of constant motion. Planets migrated, their orbits shifting under the gravitational influence of their neighbors. And it was during this cosmic dance that a cataclysmic event occurred, an event that would shape the destiny of Earth and give birth to our faithful companion, the Moon. Section 5. Thayer's Embrace. In the vastness of space, a Mars-sized object now known as Thayer was on a collision course with Earth. The impact, when it came, was cataclysmic. Thayer slammed into the young Earth with unimaginable force, vaporizing itself and blasting molten rock into space. The debris from this collision, a swirling cloud of molten rock and dust, was caught in Earth's gravitational pull. Over time, this cloud cooled and coalesced, forming a ring around our planet. And from this ring, a new world emerged, the Moon. The Moon, born from chaos, would play a vital role in Earth's story. Its gravitational pull stabilized our planet's rotation, creating the regular seasons that would be crucial for the development of life. And as the Earth cooled, the stage was set for the next chapter in our planet's incredible journey. Section 6. Water, water everywhere. The fiery chaos of Earth's early years began to subside. The constant bombardment from space lessened, allowing the planet's surface to cool. Water vapor trapped in the atmosphere since the planet's formation condensed and fell as rain, forming the first oceans. The source of Earth's water is still a subject of scientific debate. Some believe it originated from icy comets and asteroids that bombarded the young planet. Others suggest it was present in the rocks that formed Earth, gradually released as the planet cooled. Whatever its origin, water transformed Earth. The oceans, vast and deep, covered much of the planet's surface. And within these primordial seas, the stage was set for the greatest show in the universe, the emergence of life. Section 7, Life Finds a Way. The early oceans were a chemical soup rich in organic molecules. These molecules, formed from simple elements, combined in complex ways, creating the building blocks of life. Volcanic vents pumped out heat and chemicals from Earth's interior, creating environments where life could take hold. These vents provided the necessary energy and nutrients for the first life forms, and somewhere in this primordial soup, a spark ignited. This spark was the beginning of a process that would lead to the first living organisms. The exact details of how life arose from non-living matter remain a mystery. Scientists have many theories, but the precise mechanisms are still unknown. But we know that around 3.5 billion years ago, the first single-celled organisms emerged. These tiny life forms were the pioneers of life on Earth. These simple life forms, ancestors of all living things on Earth, thrived in the oceans, harnessing energy from the sun and replicating themselves. They began the long journey of evolution. Life, once it took hold, began to shape the planet. The interactions between these organisms and their environment led to significant changes in Earth's atmosphere and surface. Photosynthetic organisms such as cyanobacteria evolved, releasing oxygen as a byproduct of their energy production. This process, known as photosynthesis, was revolutionary. Oxygen, toxic to many early life forms, began to accumulate in the atmosphere, setting the stage for a dramatic shift in Earth's history. This shift paved the way for more complex life forms to evolve. Section 8, Oxygen, the double-edged sword. The rise of oxygen in the atmosphere, known as the Great Oxidation Event, was a pivotal moment in Earth's history. This event, occurring around 2.4 billion years ago, marked a dramatic shift in the planet's atmospheric composition. It spelled doom for many anaerobic organisms. Unable to survive in the newly oxygenated environment, these organisms, which thrived in oxygen-free conditions, faced extinction as oxygen levels rose, but for others it paved the way for a new era of life. Aerobic organisms capable of using oxygen for energy production began to dominate. Oxygen allowed for the evolution of more complex life forms, organisms that could harness the power of this reactive gas to fuel their metabolisms. This process, known as cellular respiration, became a cornerstone of life. It also led to the formation of the ozone layer, a protective shield in the upper atmosphere that absorbed harmful ultraviolet radiation from the sun. This layer was crucial in allowing life to thrive on land. With the stage set for complex life, the pace of evolution quickened. The diversity of life forms expanded rapidly, leading to the emergence of new species and ecosystems. Multicellular organisms arose, diversifying into a dazzling array of forms. Coral reefs, forests, and other complex ecosystems began to take shape. From the depths of the oceans to the shallow seas, life flourished, transforming the Earth into a living planet. The once barren and hostile environment became a vibrant and dynamic world teeming with life. Section 9. A planet in constant flux. The Earth, far from being a static stage, was in constant flux. The planet's continents, adrift on the semi-molten mantle below, collided and rifted apart over millions of years. Supercontinents formed and broke apart, each configuration influencing ocean currents, climate, and the evolution of life. Volcanic eruptions, earthquakes, and ice ages punctuated Earth's history, shaping the landscape and influencing the course of evolution. Species arose, flourished, and went extinct, driven by environmental pressures and the relentless engine of natural selection. Through it all, life persisted, adapting and evolving to meet the challenges of a changing world. The Earth's story is a testament to the power of life's resilience and its remarkable ability to thrive in the face of adversity. Section 10, Our Pale Blue Dot. From its fiery beginnings to its transformation into a vibrant living planet, Earth's journey has been nothing short of extraordinary. Billions of years ago, our planet was a molten mass, a fiery ball of chaos. Over time, it cooled, oceans formed, and life began to take hold. It is a story of cosmic collisions, volcanic upheavals, and the relentless march of evolution. These events shaped the world we know today, creating the conditions necessary for life to flourish. And at the heart of this epic saga lies a profound truth. Earth is precious, unique, and irreplaceable. Every mountain, river, and forest tells a part of this grand story. As we look out at the vastness of space, we are reminded of our planet's fragility, a pale blue dot suspended in the void. This tiny speck is our only home, a sanctuary in the cosmic ocean. It is the only home we know, the only planet we know of that harbors life. From the smallest microorganisms to the largest mammals, Earth is teeming with life in all its forms, and it is our responsibility to protect it. We must act as stewards, ensuring that future generations can also call this planet home. Let us honor the incredible journey that brought our planet to this point. Each chapter of Earth's history is a testament to its resilience and beauty. Let us cherish its beauty, its diversity, and its delicate balance. The forests, oceans, and skies are all part of a complex web of life that we must preserve, and let us work together to ensure that Earth's story continues for billions of years to come. By embracing sustainable practices and protecting our environment, we can safeguard the future of our pale blue dot.